welcome to the first general body meeting for engineers for the single world of the semester. We're very happy to have you here. And we're just going to go through kind of our typical general body meeting procedures. So our core principles are design, educate, build. This is the first part of our meeting. We're actually going to kind of go out of order, but we're going to build the relationships within our community. So we're going to do just a little icebreaker. If you just want to say your name, your major, your year, and what interests you about sustainability in ESW. I will start. My name is Michaela Ferry, and I'm the president of Engineers for the Sustainable World. I'm a civil engineering major, and I'm in my third year. And I am really passionate about green infrastructure and water sustainability. So just want to go down to the row. Megan?
I'm Megan. I'm the vice president. I'm a third year mechanical engineering student, and I really like renewable energy and just anything sustainable.
Hi, I'm Lauren. I am an aerospace engineering major. I'm in my third year, and I've always been really interested in sustainability, but specifically with aerospace, I want to help clear up rocket fuel emissions as well as research more into different uses for carbon, so it doesn't just break down and go into our atmosphere.
Awesome. And if our friends online want to go before we forget about you guys, hopefully we can hear them.
Hi, I'm Isabel. I'm a mechanical engineer major, and this is my sophomore year. I was always really interested in sustainability, and since I'm an engineer, I am excited to combine the two.
Who's the M? Go ahead, Claudia. Okay, or JP. I can only see your initials from here, but anyone wants to go.
Claudia, oh, that's it. John.
Oh, okay. Well then, go ahead.
My name is Ariana. I'm a first year civil engineering major, and I've always been interested about sustainability, more so like how we can better the environment.
Awesome.
Hi, I'm Riley. I'm a first year computer engineer, and I think sustainability is really cool and creating less of a carbon footprint, but also being able to use engineering to like help that and create things that I don't use.
Awesome.
My name is Joe. I'm in cybersecurity. I just want to see what I can find out recycling.
Sure. Awesome.
My name is Mohammed. This is my first year as a graduate student in Master's in Civil Engineering. I'm interested in sustainability since, in civil engineering there's a lot of pollution and such things. So, you know how to mitigate such things and stuff. That's why I'm.
Hi everyone, I'm Rico. I'm a third year chemical engineering student, and also like my friend Mohammed said, that in chemistry and chemicals there's a lot of pollution that's caused, and I want to see what we can do about that and try to minimize it.
Dr. Henry?
Hi everyone, I'm Dr. Ruel McKenzie. I'm the faculty advisor for Engineers for a Sustainable World. My major was chemical engineering, but I'm a faculty in polymer science and polymer engineering. Technically, I don't have any more years ahead of me, but I have not been a student for a while. And in terms of sustainability, I don't mean to be cheesy around my kid, but since I am a parent, I actively think about tomorrow all the time. And being a scientist, I know that the world he will inherit is not the same world that I inherited. So I'm actively trying to make sure that he gets a better one.
And Dr. Peck, would you like to do our icebreaker?
Sure. So I'm John Peck. I'm a faculty member in geosciences. I'll tell you a lot about what I do in the presentation coming up. But similarly, we know you're going to inherit a world far different than what we have. We have a really good idea what it's going to be like. And I have hope for it because clubs like yours, it's day 3 of the semester and you already have a meeting and an outside speaker. So if you're prepared for these things, you can figure out how best to cope with it. And you do it as a career as well. You can make the place a better world and have a career in it.
Drugged in, walked in a little late. That's okay. Would you like to do our icebreaker? You just want to say your name, your major, your year, and what interests you about sustainability?
Sure. My name is Dresden. I'm majoring in mechanical engineering. It's my sophomore year. And I'm very interested in incorporating green energy into the space program.
All right. So feel free to connect with us on all of our social media, especially our LinkedIn. I mean, our Instagram is run. Lordy does a fantastic job as our social media coordinator, but our LinkedIn is an amazing resource. We're going through, I try to update it regularly, connecting with companies that focus in sustainability or have aspects of sustainability in them. And so if you're looking for a co-op or a full-time position or an internship or anything, our LinkedIn is an incredible resource for that. So you can find all of this on our website. And please join Slack. This is what we use for all of our short-term communication. And it's very easy to join. If you have any questions, you can always ask one of the officers. We actually can just send you an email invite for Slack, which is probably the easiest way to do it. If you want to pull out your phones right now and subscribe to our email or Slack channel, you can do that. I'll give you a few seconds here.
And if you got the email today that there was a meeting today, then you are already subscribed to email and ready to go.
Yes. We don't send too many emails, I promise. We actually had a discussion about how many emails is too many. All right, so as far as our other general body meetings, today we're going to be hearing from Dr. Peck. Next week, next general body meeting on September 15th, we will hear from Dr. James Egan about plastic recycling and sustainability. And then after that, we'll hear from Dr. Andy Knoll about renewable energy and energy consumption. Our next two are to be determined, but we have some very exciting contacts that we are working with to try to set that up for you guys. And for our fall opportunities, this is just a glimpse into what ESW could do for you. And if there's something that's not on here that you would like to see, please reach out to Megan or I or any of the other officers. We're the only two that can make it today, but that's okay. But pretty soon we will be trying to put together a trail cleanup where we'll go hiking and then probably we'll get ice cream afterwards. We're going to do an ice cream social. We're going to do our own take on the JCPenney Suited Up event where we will go to a secondhand store and purchase our dress clothes that way. And just a bunch of other fun stuff. And we do have some officer opportunities that will open up at the end of this semester, so going into the spring semester. If you're at all interested in becoming an officer, we're actually having an officer meeting tomorrow night at 6:45 at one of those octagon tables in Coleman Commons. If you would like to just stop by, introduce yourself, and kind of see how our officer meetings go, that's a really good opportunity. Obviously, it's not required for anyone except us officers, but all of these positions will be open because we have all these people who are going to be graduating at the end of the semester. And we do have a new workspace in Olson Research Center. It's an amazing room. Thank you, Dr. McKenzie, for putting that together for us. And on other great news, we were awarded Outstanding Chapter at the ESW National Conference in 2021. And then just a few quick other opportunities. Normally I would take more time, but because of our technical difficulties. So the education team is run by Megan. They fill out part of the education pillar of ESW, and they do presentations to local schools, and you can make your own presentations for really any age group. Some of the projects that they have put together have just been phenomenal. So if you're interested, go ahead and fill out the when to meet, or I think they're linked in the emails. And then Bike Power, so these next design teams fill out the design pillar of what we do. So Bike Power is run by Anna and Megan. They could not make it today. But basically what they're doing is they're transforming a conventional bicycle with a generator like this to use that mechanical energy from pedaling your bike to charge your phone, power lights for safety. So that's a really interesting project. And then we have the educational wind turbine. Their end goal, they're actually hoping to finish at the end of the semester. So if you are interested in joining this, they're at a really exciting point where you're going to get to see it all come together. But the end goal is actually to one day make this wind turbine portable and take it to local elementary, middle school, and high schools to show them about wind energy and how feasible it actually is. And then we have this precious plastics, probably our most popular design team so far. Basically what we are doing is we are creating an on-campus plastic recycling center. And eventually, years down the road, students will be able to come and 3D print their own new materials like cups, plates, you name it. Whatever you can dream to make out of plastic, we'll be able to do it. And then we are actually hosting an event in the spring called Future Earth. It's for middle school students in the Akron area. And it's going to combine design challenges. They can do TED Talks about areas of sustainability that interest them, tours of the university, and to talk about what ESW does and how they can find a career in sustainability. So if you're interested in helping us plan this event, there is this QR code up here, and I can always pull this back up. So we talked about, we have our hike and trash pickup coming soon, our ice cream social, and there is a Perkins Beach cleanup coming up on September 25th. It's in Cleveland. We will offer carpooling if you're interested, and you would sign up for that through Drink Local Drink Tap, but that will be coming out in future emails as well. And so then without further ado, I'm going to introduce Dr. John Peck. He's a geology professor and researcher at the University of Akron, and he specializes in sedimentology, pollution histories, and dam removal and lake mirrors. He has also collected lake sediment cores from research teams around the world to better understand climate change. So Dr. Peck, I will go ahead and relinquish power over to you.
Well, thank you for the invitation to speak to your club. I'm impressed. Here it is, day 3, and you're so organized. So the introduction covered what I do. I've been very fortunate in my research career to go around the world to do this work. And the reason we go and look at lake pores is that meteorological instrument records are only about a century long. So if we really want to understand the Earth's climate variability, we have to go and look further back in time and find out, are the extremes wetter, drier than what the instrument shows for the past century or two. So that's why we go and core the geologic archive of climate change. And then I do a lot of the similar kind of things on how humans are modifying the environment, a lot of dam removal here in Ohio and pollution histories. And what I'll talk to you about tonight is the recent hydrologic change that we are all living in here in Ohio, and how it has likely to continue in the future, and adaptive strategies that we're going to be forced to undertake in order to live sustainably in Northeast Ohio. You can also think of these as careers and job opportunities. So before I run out of time, I want to thank some organizations, but mainly Akron students that have worked with me on this over the years. A whole bunch of undergrads and graduate students for their theses, and I'll show a lot of the work that they and I have done together. So as an outline, the first topic will be introducing the value of balanced river environments. And I'll show how they're thrown out of balance. And I can even tell you the day it happened. July 21st, 2003, we crossed the tipping point here. And then, now that we're out of balance, that's not a good thing, some adaptive strategies that need to be implemented. in order to live sustainably here in Ohio. So on to the balanced environment. A stream is way more than its channel. It's all these surrounding environments. In fact, it's everything within the watershed. So the forested uplands trap water. The floodplains store floodwaters. And this aspect is critical for all engineers to appreciate and all of society to appreciate. A healthy, well-functioning stream floods, and it laterally meanders. And we just have to learn to deal with that. Things get really out of whack when we try to confine the channel from a functioning stream to a ditch. The floodplains uptake nutrients, they filter out sediment and contaminants. The vegetation provides stability of the banks, and all of this leads to improved water quality. So we need to think system-wide and not just flow in a channel. The way streams operate was well illustrated by Lane, the civil engineer. This is 70 years ago. He came up with this model, and it's called the lane balance. It is so good, I brought in one, and I'm hoping people out there can see it. I think I just have to move this tray. Can everybody see it in here? I get the problem. And so what it represents is the balance between energy of a stream and the resistive forces. And over on this side, we have the resistance, which is provided by dead load transport. That's represented by the sediment in the bucket and the grain size of the sediment on the bed. And the coarser it is, the further out you're out on the lever arm. The energy in a stream comes from two sources. It comes from the water discharge, which is represented by that nice picture of water or my beaker of water on this side. And also energy comes from slope, right? Water runs downhill due to gravity. And this is the slope energy. And so the resistance is balancing the energy, and the stream is said to be in dynamic equilibrium when, even though it's eroding and transporting, if the overall plan form stays the same, if what comes in and what goes out of the stream channel is relatively the same, it's in dynamic equilibrium. Yeah, it's eroding and depositing, but it's in this dynamic equilibrium. And I just want to balance this out so that we start balance. Is that level?
A little bit more.
Tell me when.
Keep going. Okay.
And so when the energy is balanced by the resistance, that needle is pointing to the middle. If you perturb any one of those four things, you throw it all out of balance because they're all interconnected on the pivot. And the needle will either point to aggregation or deposition or degradation, in other words, erosion. And we'll talk about that in a minute. This can be quantified. Lane quantified it, students and I quantify it. We do it in time series when we're looking at dams. But the value of this is the river's vein physics. And we can make predictions. If we change a certain thing, what's going to happen to our river system? We don't just have to be surprised by things. We like to know how quickly things happen, and then you have to measure individual sites to really get the rate. But we can understand what the prediction is going to be here. So we're in a balanced river system. Energy is balanced by the sediment resistance. But things don't always stay fixed through time. And what's happening in a lot of the world is we're increasing heavy, extreme precipitation events. So this is one study where they looked at the 48 US states and they analyzed thousands of rain gauge records. And all these red triangles are where there's a significant increase in increased extreme rainfall. The dots, no trend. The little blue is a significant decline. The thing to take away is we live in the sweet spot of increased heavy rainfall. The upper Midwest is a regionally coherent area where these heavy rainfalls are becoming just more frequent, more intense. And that water has to go somewhere, right? Why is this happening? It's complicated. What happens in some locations is determined by far field effects. So we have these atmospheric centers of action over the oceans, and they help control the steeriness, the jet stream. And we know, well, other people know this, and they publish papers on it, that when we have certain high pressure or sea surface temperature in the Atlantic and the Pacific, the jet stream goes to different locations. The low pressure systems that bring the rainfall track along the jet stream. So there are coherent, statistically significant linkages between far field change and when we are wet in our part of the world, the upper Mississippi River Valley, or when we're dry. Furthermore, we know as the Earth's atmosphere warms because of we humans, it holds more moisture, about 7% more moisture every degree Celsius. We know, just from observational data, this is just observable fact, that the jet stream is moving poleward in the northern and southern hemisphere. That's where the low pressure is trapped. And we know that the convection increases in a warmer atmosphere, and that helps lead to these heavy rainfalls. So the understanding behind this is good. And we just happen to live in a place where it's really robust. So where does that water go? Well, some of it goes into the rivers. So here is a graph. We'll spend a minute on. This is mean daily discharge of the Cuyahoga River down in the Merrimack Valley. So you're looking at time from 1985 to last week when I put this together, and you're looking at discharge in cubic feet per second. Every dot is a day. So if we look at it carefully, these tick marks are January 1st of the different years. And what you'll notice is that in the winter and the spring months, the discharge is high in the Cuyahoga River, and in the summer and fall, the discharge is low. And that's simply because in the summer and the fall, the trees, I want to say drink the water, they do transpiration, right? Trees use the water. We just have pure physical evaporation in the warm air, and the ground's not frozen, so some of the water infiltrates. So that's the annual cycle. High in the winter, spring, low in summer, fall, and then boom, July 21st, 2003. This is a sad day. 2 people died in Hudson, Ohio. They were electrocuted in an underground parking garage. This did widespread damage. So widespread, they flew aerial photography right after it to document the damage. And now you can see the number of increased high floods in the Cuyahoga River. We've crossed this threshold. And we look at this a whole bunch of ways. We can do competitive statistical tests, and there's a change point right here, and that holds up if I even throw in more years of data. You can kind of see there's more white space here than over here. The mean is up. But let's just count the big days. In this 18-year period, 14 top 1% floods. In this 18-year period, 67 days. So it goes up almost 5 times beginning here. We just have more frequent intense rains, more frequent intense high magnitude floods. So now we're going to go back to the lane balance, and we can make a prediction on what's going to happen when we have more flood water. And anybody want to take a stab? I blew it up for people in the back. If I have more rain coming out of the water, out of the atmosphere, into my rivers, what's it going to do to this balance? What's it going to, yeah. And then where's the needle going to go? To degradation, right? So we can, this is the value of rain, and it all can be quantified. So here comes the big rain event. This could have been a big rain in 2019, all the way back in 2003. Absolutely, right? So your hypothesis works out, and the balance, it's out of balance. It's out of equilibrium, because it has new high energy conditions. So what is the stream going to do? Well, Lane told us 70 years ago, all these other things have to change because we have more energy that it needs to come into. So let's have some erosion. We'll go over the Yellow Creek, the watershed of the Cuyahoga. And with all that extra energy, we can do eroding. And now the footing on a bridge piling is daylighted. This is really bad. This was underground. So you got to just dump a dump truck of gravel to try to get that footing buried again really quick. Right? So more erosion. It's going to wash out the fine sediment and leave it more coarse. So I can work on that. And I'll bring this out to the edge a little bit. And as the fines get flushed out, we have greater roughness and more resistance to the flow. And then here's another really take-home message, right? Rivers flood, that's healthy and normal. The meandering, the erosion is a good thing. So what the river is doing, I know it's a thing in physics, I like to think of Red Lane's paper. What the river's doing by lateral erosion is it's decreasing the slope energy. Right? The river comes in at an elevation, it goes out at an elevation. So the rise is fixed. But as it laterally meanders, the run becomes really big. And that's the denominator, the slope. So now the slope energy gets less. So I can now make it less steep. And I'll move this in a little bit. So that lateral erosion, yeah, I know it took out somebody's structure, and that's sad. But it's doing it for a physical reason. It's lowering the slope energy. And now it's attained a new dynamic equilibrium with the new high energy conditions. How long does it take? It depends, right? When we study dam removals, about 3 years for the Roe Falls Dam, for it to deal with the new conditions. It depends on the local setting. But over time, it will readjust to its new thing. And it wants to do certain things, like laterally erode. But if you have a fixed structure, you may not want that. If you just keep the channel fixed, the energy has to go somewhere. It's going to have it downstream. So with that as like the underlying idea behind what we're experiencing, we are out of balance right now. Let's look at some data from around here. This is the Cuyahoga watershed. It goes from Geauga to Akron, makes a U-turn, goes to Cleveland. And we'll look at Furnace Run and Yellow Creek sub-watersheds that the students might have studied. And we'll do it in a series of photographs. So Furnace Run sees more rainfall after 2003, more floods after 2003. I'll show you some air photos. There's the year, 1994. The blue line is the river in the year 2000. And then the red is a reference that won't change. There's a dot in the river here. The dot's in the river with this line. Nice big farmer's field. And in the 90s, the photo and the blue line are pretty much the same thing. It's in dynamic equilibrium. There aren't that many floods. Now we go to the year 2000. The photo and the line are the same. It means one can digitize well. That's all that means. But now let's come after the floods. What do we have? Well, the river stops to do what the lake balance says. So it has migrated a full channel width. It has migrated, it's becoming more sinuous, lowering the slope energy. It's starting to flush out the fine material. Just do another one, 2018. Here's the fines in the Cuyahoga River on their way to Cleveland. Furnace Run flows from the covered bridge down here. Look how sinuous this is. That field's long gone. It's almost coming up to the hill. So it's lowering the slope energy. It's sending out the fines, leaving the course behind, transporting more bed load, trying to come into a new equilibrium. And we quantify all this. And that's shown here. It's time from 1981 to 2011 with Adam's work. And there's a few records here. Here's Hiram precipitation. We looked at a lot of rain gauge records. The reason the bars are different widths is because they fly aerial photography at different times. So they represent the time between air photos. So we have to normalize the data by how many months are in these bars. So these are heavy precip, Hiram rain gauge, normalized per month. And you can see there's very few until 2003. Then they become more numerous. And it's in the mini rain gauges we look at. Here's the flood record that we just saw, but presented slightly differently. Very few big floods until after the heavy rains come. Then we have more floods. And then here's the area eroded in that lower Furnace Run. Very little square meters eroded until the big rains come, big floods come, lots of erosion, all kinds of change. You could ask the question, well, maybe it's not the climate. Maybe it's development, people building in the watershed to get more runoff. So we look at that as well. We look at national land cover databases, and you look at the amount of development, more runoff into the channel. And that goes up about 1% every 5 years. There's nothing special right here. So this is priming the land surface for when the climate changes and you're in a new hydrologic setting with all this erosion. In Yellow Creek, which is the watershed a little to the south, the beautiful thing about this watershed is we could finally divide it into 5 sub-watersheds that have different characteristics. We can really tease out the role of other variables on runoff and stream discharge. So we instrumented the heck out of it, we measured many different locations, and we know the rainfall matters, the climate matters. We looked at the slope, steeper slopes, more runoff into the channel. And generally, the reds and yellows are steep and lower, Yellow Creek, and the greens are more gentle to the west. We looked at development, that's absolutely the impervious surface. This is Surrey Run. You think all the malls out on Route 18. I think goes on, it's just opaque. And then to the north, Bath Creek, very undeveloped land cover. And then the hydrologic soil group. Different kinds of earth material have different runoff potential. So over to the west, they're the type of earth material that allows a lot of infiltration, little runoff. The reds are a clay till subsurface, very impermeable. So when the water hits the ground, it runs off differently. So we could even assess these factors. And the punchline is the change in the climate, change in these extreme rains. And again, real quick, same deal. The year of the photo, year 2000, a dot that'll show up in a lot of these. In the 90s, they're the same. The photo and the channel, it's in equilibrium. That one can digitize well. And then here's the photo from right after the first big rains, big floods. And you can see the river cut off, this meander loop, just blasting on through. So, right, we talked about it, trying to lower slope energy. Here we need to run a lot shorter because it's just such a high velocity. There's a new house that was developed here. Here we are, 2005. We start to see some erosion of channel margins. It's 2015. It really jacked this up. It flooded. You can see the channels now really eroding. So it's moving, it's on the move, it's moving all kinds of sediment through the system. A different location, Lower Yellow Creek, same kind of thing, but more quantitative. So it's 1985 to 2015, and we just got the middle one. This is the flood frequency, we've seen it before. Very few until after July 21st, 2003, then they're much more numerous. Here is sinuosity. That's the meandering nature of the stream. It's low. The floods come. We have all this lateral migration trying to lower slope energy, and that purple line just goes up as this thing meanders all around. The green is unvegetated sand. We digitized and mapped that. There's a little bit of it, but not that much sediment on the move. After that, it is just sandbars heading on down. And that causes differences in habitat, deposition, different locations. And again, here it is, now it's called the percent imperviousness, which has a coefficient to development type, watershed land cover type. And it's just no major change, just steadily increasing. It's all under 10% imperviousness. That's considered a threshold where streams start to see adverse runoff. So it's absolutely the climate causing that change. And one last photo. Yellow Creek coming in at the bottom, here's a dam pool, and Yellow Creek flows this way. 1994, little tiny vegetated delta. 2000, same delta, no change, because it's in equilibrium. Here's the air photos they flew right after the flood. Whoosh, all of a sudden it's coming down, being trapped in that pool. Here we are, 2012, here we are, 2015. Right, it's doing just what this said. Sending sediment on its way because of all this increased energy. So our streams are out of balance from what they had been for decades and decades. And why does that matter? Who cares, right? One of the big things is what I call this legacy sediment is being remobilized. So here we are in Yellow Creek, a lot of energy eroding the banks, it's heading towards that house, but Yellow Creek is eroding good old dirt. It's eroding glacial sediments, soils, alluvial sediment. Here's another river we studied. This is the Little Cuyahoga River. That's the All-American Wide Bridge right here in Akron. And it too is experiencing more floods, but it is eroding the old landfill, contaminated material. This is a toxicity level for lead measured in the bank. So now a lot of hard work people do to minimize pollution in the environment is sort of being negated because we're taking old pollution from the early part of the 20th century and getting it back in the environment. So that matters. The floodplains, so a stream, all that erosion, it gets incised, it gets separated from its floodplain. So when the next flood comes, it's even more damaging because it doesn't have access to that. Which, of course, changing habitat in the sediment structure, and then the bank stability, right, for the civil engineers, the structures, they're susceptible to damage all along these rivers, right? Anybody live near Peninsula or drive up the road and had it closed all summer because the Cuyahoga was coming to the road, Peninsula didn't have the $2 million to fix it, so they just said, we'll close the road, wait for the state and federal agencies to pony up the money, and then they stabilize the bank so you have a road. Sometimes you have to keep the structure. Sometimes you're better off keeping the structure. So that's what we're living now. What's it going to be like in the future? So in preparation of today, I went online and took this from the Intergovernmental Panel on Climate Change, the 6th assessment. This is like two and a half weeks old. So you can go online and get it. And I looked at the executive summary for like presidents and prime ministers and kings and dictators. So we boil it down to a 40-page summary. And what we're looking at here are gigatons of carbon dioxide. That's the greenhouse gas that causes warming versus time. We've lived this portion. Here's to 2015, 2020. What's going to happen in the future, right? So they can do projections. In my opinion, this is very unlikely. Right, so this is a model, this blue line, where very soon the nations of the world decide to reduce our greenhouse gas emissions drastically. That requires a lot of cooperation, different thinking, and that gets us down to not adding carbon in the year 2050. And I picked 2050 because it's one of the time windows that they look at. And if we think about it, you're 20 years old, 2050 is 30 years from now, you'll be in your 50s. You'll be right in the middle of your working career. So this is not a geologic time, a million years from now. This is in your working career. I'm hopeful we're going to follow something closer to this. I'm hoping we don't do the same old, because there's a lot of very expensive consequences of that. But this one has us basically leveling off our CO2 emissions mid-century and then make an event in it. And that would be a 2-degree warming. It's all relative to pre-human major impact, which was the last part of the 19th century. We've already had 1 degree Celsius warming in the last 120 years. This model says we're going to get another 1 degree in the next 30. Even if we go super optimistic, and I'm an optimistic guy, but that's asking a lot. Even if we do this, we're still going to warm up. And they can model what are the effects of this. So even if we're in this, the heavy rain, what's considered a 10-year rain event, once in 10 years back here, is now 1.5 times more likely, and it's a bigger magnitude event. That's globally. Locally, people do regional climate models. And it's the same story, right? We're already seeing them, they're just going to get bigger and more intense. And in this one, the meteorology behind it is you warm the atmosphere, the Bermuda High out in the Atlantic intensifies, the south to north wind picks up, and it brings moisture from the Gulf of Mexico to the upper Mississippi. Our rain comes from the Gulf of Mexico. It's not Pacific Ocean. And this would just get more intensified. So these rain events would be bigger, 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 more intense, more rainy. Hopefully nothing like we saw in Tennessee. Last Saturday, we could go right 17 inches in one day. But we're going to get bigger. And it's just going to keep on going. So that brings us to this portion. How can we better achieve a balance between a healthy, functioning river environment and still be able to live and work in the watershed? Right? That should be our goal. We don't want to live and work in a lousy, hellish place. Right? We want to live and work in a place, a natural system that functions healthy, has great recreational opportunities when you're not stuck at work. You can go have some fun. And plus all the other components of the ecosystem out there. It's not just people. They're all doing pretty well as well. And that comes in sort of two categories the way I think. One is local. And the local thing, the key is reducing the runoff. So as the rain falls on the land surface, we need to have it stay where it falls longer before it enters the channel. And there's all kinds of engineering structures and methods to infiltrate that rainwater. If we reduce peak discharge, that's huge. And keep a healthy functioning river. Connect it to the floodplains. They're doing that now in the national park. So their companies do the engineer design, construction companies do it, get these systems working together again. The vegetation's huge. And then this is a key one, plan for more big floods. When I talk about this topic to like the Akron, the area, Metropolitan Transit Authority, years ago, they're like, oh, this is why we have to vacuum out our storm drains. In the old days, there'd be once in a blue moon, they'd vacuum out all the silt. Now they're doing it constantly because we're in a new hydrologic regime. So you can plan for this. In the old days, a culvert like this might have sufficed. Better get this one, because it's a different hydrologic regime we're working in. And then globally, this is a tough one. And I heard some good things about working on fuel and all that. We're going to need to reduce our CO2. And we got to keep that warming 2 degrees or less by 2050. And I'm optimistic it can be done. And why, you know, it's pretty scary stuff that's coming your way in your lifetime, 30 years. But if we think back on other things, I mean, there was a time the Cuyahoga River was just, mosquitoes wouldn't live in the lower Cuyahoga, it was so bad. And local environmental activists and citizens group sort of held the politicians accountable, and government agencies thought really creatively, and then engineers figured out new ways of doing things that didn't cause the pollution as before. And we go from something that was really bad to something that we celebrate. So I think knowing this into the future prepares people to figure out how to cope with it. And earn a living doing it. There's nothing wrong with that. So thank you for listening.
Does anybody have any questions for Dr. Peck?
I was wondering if I could ask, you said that like we could knock down the day, like it was July 21st, 2003. What exactly happened that day? Why is it so significant?
Yeah, so some systems, instead of just gradually changing, sort of jump between states. So at that time, we had a major shift in the state of how the precipitation, how the meteorology operates. And some of it sort of superimposed on all these increased floods that just get more and more numerous are longer scale, sort of decadal scale variability. And if things just kind of constructively add up, you can get yourself into a situation where instead of just a gradual incremental increase, you go from one state to a different state. And that's what we did. We jumped into this whole new way of all these heavy rainfalls. Yeah, yeah. And in the 2000, there's another data set on that slide that just blows my mind. You look at the top 10 floods of the Cuyahoga River down in the valley. 7 of the top 10 happened in the last 18 years. The other 3 happened in the earlier 80 years. So it's different now. And I think the science on warming and how the atmosphere works is pretty solid. But regardless, we know this is happening. We have to plan for it and deal with it.
Let's give him another. Did you have a question?
I was just gonna say, I feel like when I talk to my grandparents or maybe an older generation where they've seen it before, when in our lifetime I've seen more catastrophic once in a lifetime events than I can count. But to that, I don't think they understand that significance going forward because they aren't going to be here to experience those effects. how do you take up that discussion with people who may not feel those effects down the road?
Yeah, that's a tough one, right? So, and that's why I'm not so optimistic about that light blue line, because that takes people, societies thinking beyond the immediate need of just them, but thinking collectively. I'm more, but I'm hoping, I mean,
Yeah.
you know, you young people change the world, because we haven't done it. Maybe the orange line is more likely. So one aspect is sort of this altruistic that I want to see everybody doing better. And I don't have to have a world where I'm in it all for myself and I'm getting that way at the expense of everybody else, right? I can still do well for myself and other people can do well as well. And sometimes that works, it depends on the people, right? A different approach is that there are no free lunches at all. So why do I care about hurricanes that hit the coast of the US? Because I pay taxes and FEMA goes and spends billions upon billions, tens of billions of dollars to rebuild after Sandy, after Harvey, after all these hurricanes. So from that point of view, even though I'm here in Ohio and bring it on, storm surge, you know, 1,000 people at sea level, the taxes, right, the money thing. There are no free lunches. And now I can even take the view a little bit bigger. I live in the US, right? So I am, you know, I work all over the world. And every time I come back, I'm like, so thankful. Because I don't appreciate what I have on me. And then I go to these places and see what most people live with, right? But even at that scale, there is no free lunch. Because if a place totally collapses, it's going to hit the pocketbook of the world. The agency that really understands the no free lunch is the Pentagon. So we have 3 national security assessments. Nuclear weapons, because that's a threat to your security. Terrorism, because that's a threat to your security. Climate change at the Pentagon. And the reason the Pentagon has that is because they know if the climate change, especially at the low latitudes, they're going to get hit hard. Like if Nigeria just totally collapses, these big mega cities collapse, then the military, the US military, which is great at logistics, is going to be involved, and they need to plan for that. They need to know how many transports and ships and planes and what they need. So the model they pick, and I guess they know a lot more about planning than I'm picking the orange line, and both. They pick, if you're going to plan, they pick the worst case scenario in their third security assessment. And they plan for that one, which I see that makes sense, right? You'd rather have more than not enough. So that's the way that appeals to some people. And it's a delicate issue, right? So you don't want to fight with people, especially your grandparents. And I'm sure they've seen all different kinds of things. And so when you talk to older people and they tell you about snow that was, you know, it was real. You don't get to quite the amount that they had. So I guess being respectful is a way. It's a tough one. Do other people have strategy? I mean, that's the crux of it. So I talked to a group that's called Hands-on Sustainability Akron. So these are, you should email, I put in touch with Mary in January. She's an engineer. Yeah. So these are great people, right? They made me come up, they asked me to come up with 5 bullet items on affecting positive change. That's a different one. But the really important one is vote, right? So you want to vote for politicians that share whatever your values are. Because the engineers and the scientists can figure out how things work and figure out, you know, technical solutions to things, to incredible decimal places, but it requires the politicians to enact the policies, right? And that's what we're about by voting. So that's a key one. And you don't have to convince everybody. I think in the US, in many elections, not everybody votes, right? So that's a way to bring about change. And sometimes it works great. If you think in the early 70s, we got the Clean Air Act, the Clean Water Act, the US EPA all at once. So it was just this, hey, we're gonna do something about it. So sometimes the politicians come through in a big way, but it requires everybody. You don't have to be an engineer, right? So it's the human and social sciences.
That's a really good segue. We actually, on our YouTube channel, have, I think, 2 lectures from Dr. something from New Hampshire University, but on our YouTube, we did
Dr. O'Sullivan.
Dr. Terry O'Sullivan, there we go, about voting for sustainability, and then he did another one about just general like politics and the environmental issues. And then this meeting will also be on YouTube. If you have a friend who didn't come today, you can make them watch it. And then they'll be like, wow, I'm gonna come to the next one. But on that note, let's please give Dr. Peck another round of applause. And if you guys have any further questions about ESW or in general, Megan and I will be hanging around for a few minutes, but if not,